to do this all day today is ask you the like terms that we're combining. What are they? Are they variables or constants? So in this case, what are our like terms? The variables, right? And then do they agree or do they fight? Right? So they're both negative here, so they agree. So the other thing that I guess I could show, we don't have to show it, but this is multiplication and this is multiplication, right? Anytime there's a number right up against parentheses. So I'm trying to make sure that we can all see here. Gwen, how you doing today? How you doing with, can you see? Okay. Sorry, that just made that a little bit smaller for some reason. Stop it. Stay big. Maybe a little bit. All right, try that next one on your own. Sorry, there's the whole process for the first one still up there for you. Yep, that is the first part of it. So I'll scooch back a tiny bit so you can see the edge of it. What can I? You are making me all squinty. I mean, it doesn't suck. But... Okay, I know that my K's are weird. You don't have to judge me about it. Alright. Guys, if the glare on the screen ever gets too bad, we're still getting used to having all this crazy bright sunshine. So please tell me if the glare gets too bad. I'm a little worried that I don't see pencils moving. Are we done with the Y problem? I put this next one to the right. Like, I work my way down the page. So, if you want to see, Kiki, I moved this one over there. So, and they take up about the same amount of space. So there, I was trying to just finish showing that for another couple seconds. Anyone still need this one that's up there, or can we move on? Anyone still need this one? So then, and guys, I'm like setting goals for myself as we finish out the year. I'm going to start asking you guys to chime in and tell me what happens. So I drew the arrows beneath here because I want to start showing you guys that, like, you have options. You can draw the arrows on top of the distribution or on bottom. It doesn't change. But here's the trap door. It's not 3 that distributes. It's -3. Because this is not minus. I mean, it is minus, but remember, subtraction is a lie. When we go to distribute, this is like distributing a -3. So guys, go back and check your work. Did you do -3 times -3y? And did you do -3 times 5? So this negative, that's what's going to trip people up. That is our trap door. That you just like went ahead and found the numbers. Yeah, that's okay. As long as you like are very careful about not making any mistakes. Now, the problem is eventually you will make at least like a mistake probably. But that happens. A single, yes. Anything in red? I don't know if zooming in will do any good. So, what this says, Gwen, is -3 times -3y. I may try to write it again, like, thicker. Is that any easier to see? So that's what happens, like taking away the color coding, or really just copying it. So then we get negative y. Remember, things just drop down if they don't do anything yet. What's a negative times a negative? So this becomes 9y. Remember, it's multiplication, not addition. Negative 3 times 5? Negative 15. I like to keep my negatives grouped in parentheses. Now, highlight your like terms. We don't really need our two colors yet. We still can do one color. So, y and y. Right? You don't have to highlight the whole thing to cue your brain in of these are our like terms. So our negative 15 is lonely. I'm so lonely.
Your singing voice, I know you is much better than Justin Bieber's.
Well, that's not my singing voice. That's my fake singing voice. I was in choirs like my whole life. I have a singing voice. Do my like terms get along or fight? They fight. Who wins? Good guy, bad guy? Good guy by how much? 8. Yeah, we talked about that last week, right? If there's not... No, because this is negative 1y and this is positive 9y. The positive is stronger. Yeah, so hey, double check this, that you have negative times negative equaling a positive. You know, Gwen, if I need to take notes in Sharpie for this class, that's fine. It's a little bit thicker on my notebook, but that's fine. So the other cool thing that happens is, look, I'm an artist. This is the page that goes beneath when I write with my pens because they bleed through the paper. That's my page beneath it. It's like abstract art. All right, any questions on that one? Otherwise, you're about to try it on your own, like for real. Especially because I'm going to have to rewrite the problem. Try this one. Now, I will rewrite the original problem with you. So for those of you saying, like, wait, it's grainy, or wait, like, I don't even know what you're saying wait about, but I'm just about to rewrite it. So hang on to your horses. Literally, don't let your horses out. Probably back in the days of horses. Instead of writing minus 7, what should we write? Plus negative 7. Right? So instead of writing minus 7, we're going to say plus negative 7 times 5 plus 2n. So there we go. 2 times negative n. We can say minus 3, but our brain should say that's really a negative 3. Now I'm gonna like stop writing, stop talking for a minute. You guys should try this on your. Actually, I am gonna write. I'm gonna stop talking, but I am gonna write. I'm gonna give you a head start. You should ignore my board unless you need help. Only look at the screen if you want help. I'm gonna give you about 30 seconds, then I'm gonna start writing. if you have been at all confused, you should be writing out all of the work and not trying to skip through the multiplication. If you've been at all confused. Any questions on this? We drew the arrows. We wrote out what multiplication is going to happen. So everyone's good with us getting to negative 2n, negative 6, negative 35, and negative 14n. Now, especially because I'm working in colors that aren't like indicative of my like terms, I'm going to rewrite everything just in the same color, like all in black, to make my life a little bit easier. So everything on the right in blue came from the right distribution. Everything on the left that was in orange, now written in black, came from the left. So, negative 2n, what will be like term with that? Yeah, the very last term, negative 14n. So together, my variable values, negative 2n and negative 14n, become negative 16n. My constants, remember a number without a variable is a constant. My constants, what do those become? Negative 41. Does anyone have questions? Need me to zoom in on a certain part? Want to curse gravity? Sophia, would you like to curse gravity? I just saw whatever all fell down on the ground.
Oh, no, it's just this.
Any questions on this one? Going once. You ready to step it up? Time for harder problems. Let's look at these two. Oh, my guess is you've already been seeing them in Khan Academy. So take a moment. I want you to start before you do it with me. Gwen, are you able to see these or no? Yes? Yeah? Okay, sweet. I'm going to try to just show you guys these for efficiency's sake. So, hey, good quickness on your little jab there. That was good. Yeah, maybe we should take the quiz today. Lily. All right, so if we look at what we need to do here, well, there's no distribution, so it's all about the like terms. So remember, those parentheses there are just grouping the negative. There's no distribution that needs to happen. So it's all about the like terms there. And what do we check before we see, or what do we check to see if we can add fractions? The denominator. So if we have a common denominator, we're all set, which we do. So they get along in their bad guy efforts, and they are -6/7. No, I'm looking at an email. Yeah. All right, so our decimals, trying to make sure we have enough time to be comfortable. Same thing. Oh, not that one. Same thing. Just the like terms. Now, here's the trick of why I put this problem on here. Here's what I wanted to tell you about this problem. Clark, I hope we already did this one, and that's why we're like relaxing. Because these are all decimals with just one decimal value, like the tenths place, you can act like it's 32 and 13 instead of 3.2 and 1.3. So if we have a -32 and a +13, we could get that we would, well, the bad guy would win. But he would win by 19, and really that's 1.9. So, moving on to this one, my first question for you. Do we need a common denominator between the 8, the 10, and the 5? Ooh, who said no? Why no? You can't just throw it out there and not expect, like, you got to be able to defend yourself. Anyone want to help Bella out with why it might be no?
No. Yes, it is. Oh, wait, no. You don't, because you don't need a common denominator, because then you don't have to add 7 over 8. You don't have to add 7 over 8 with anything else. There's only a common denominator.
Now, I agree with you mostly. We don't have to add 7/8 with any other fraction here. Is there any distribution to do? No. So we immediately start looking at like terms. Guys, write this one down, and if you have 2 highlighters. If you have two highlighters, let's highlight it in different colors. Because then we realize, oh, the m's with the m's and the constants with the constants. That is us getting to a common denominator. So we realize, oh man, to combine my variable values, we need a common denominator. I know, it's scribbles is what it is. No, it's times 2 and times 2. Because the denominator for our constants is going to become the tenths. Excuse me. Yes, so the reason we did this is, do these m values get along or fight with each other? They fight. So it's not just like 2 and 7/8, right? We can't put them together. So we need common denominators to do the math because we have to say which one's bigger. Right? We have to have common denominators. Now, if you're a math whiz and you can somehow subtract 2 from 7/8 just like real easily, now you might be good and say, oh, well, that would be 1 and 1/8. Like, you might be able to figure that out of who wins when it's the good guy versus the bad guy of -2 versus 7/8. You might just know that. I don't. So I have to look at them using common denominators and then compare the numerators. So that's why I wrote -2 as -16/8. You guys ever like feel you got a pimple coming in and it just like hurts? Yeah, that's why if you notice I like keep touching my forehead, I totally have like a pimple coming in. Or I got bit by a bug, one or the other. I don't know, I'll figure it out when I get home in 2-ish hours. So our constants combine -9/8 m. Our 9/10 and -6/10 combine to give 3/10. Yes. Any questions on this? Now I can't guarantee that this week's quiz will have fractions and decimals. I might just do all whole numbers this week. But eventually, you will have to show mastery using the rational values. Gwen? Thank you. I was hoping somebody would eventually say, like, I'm confused because I'm starting to not explain so much. So thank you. We are given this expression, right, and we're asked to simplify it. So if I wasn't covering up my directions right here, my directions that I have written out, but I made it big and I rewrote it. So the directions were to simplify. Sorry, I keep giving little hints, but way back up here, we said simplify this expression. So as we talked about, I don't know if it was Monday or if it was last week, to simplify an expression, which was our header, right? Simplifying expressions, we combine like terms. To be like terms, they have to either have the same variable or no variable, right? So when we look at these, the same variable are my m's. The no variable are my constants. Are you with me on that part of why these are highlighted pink and these are highlighted yellow? Okay, what doesn't make sense about that? So, can I add, what do I even have? Can I add a Skittles bag with a Skittles bag and say that I have 2 Skittles bags? Yes, because I stole this from Mrs. Pettigrew, and I can. Now, can I say I have a Skittles bag and a Nutri-Grain bar? Yes, that's like an expression, right? A Skittles bag and a Nutri-Grain bar. Can I say I have a Skittles grain, can I put them together? No. Because I can't, if I had 2 bags of Skittles, I could put them together, and, it's all Skittles. I can put them together. But I can't, I could just, smash these together, but that doesn't make sense. So I have to sort things separately to talk about them separately. That's the same thing as like terms. So just like you could have a bowl of apples and a bowl of bananas and put them together and say, I have apples and bananas, you can't put them together and say, I got apple nanas. That sounds kind of cool. Now, I try to do this almost every morning, and I use a blender to do it, right? You just chop them all up and just put them all together. I make a smoothie every morning.
No. You have to add the pill too.
So, what we're talking about, if we come back to the simpler problems from last week, this is just my semester 2. This is a variable, we said, I forget if it was this class or not, but we said Nutellas, right? We said 7 Nutella bar, I think they make a candy bar Nutella thing, plus $2. Right? $2, you know what $2 is. It is $2 all day long. But 7, or has anyone paid attention to the GameStop stock thing going on? So stock prices are always changing when the market's open, which is daytime. So stock prices, you could say, I have 7 shares of GameStop stock, but that you don't know what it's worth until you go look it up. Last week it was worth $400 per stock. This morning it was $90. So what last week would have cost you $400, today would cost you $90. But if I have $2, I have $2. Right? So that's where non-like terms can't be put together, is a constant number is the money I have in my wallet. This is not going to change. Nobody's going to come up to me and say, hey, today, this is only worth $1.20. That's not going to happen. Stock, you don't know what it's a variable. Does that make sense? A little bit more, at least. So, if you need a lot more explaining, Gwen, fortunately, I've got my lessons recorded, and we could always go back and connect you with one of those. But now, when we're talking about the distributive property, what we talked about last week and what should be in our notes, and if you need to come copy, you can. My notebook is up here, it's sitting on my desk, but it goes here, right? It's just on my desk right now. Is that this is telling us how many groups. So really, we have half of a grouping here, but we also, on top of having just half of it, we have the opposite of half of it. So if you just want the explanation of mathematically, what are we doing? We're splitting up the operation of multiplication, because this says do the opposite of 1/2, or you can call it negative 1/2. Do that negative 1/2 times everything in here. Now, we can put a negative in its own parentheses. This does not matter. These parentheses right here. You could have those. You don't have to have those. That's why the problem doesn't have them. But what is the opposite of half of negative 3? So we write it out. So this is what I need you to copy with me, is this is every step that we do. Yes, please. So I'm going to try to get it to focus up a little crisper. There you go. When we're dealing with fractions, we might as well make everything fractions. so that we can then do numerator times numerator, denominator times denominator. The things happening here are that a negative times a negative is a positive. That's why I wrote this plus. It is unnecessary. That plus sign doesn't really need to be there. It's just indicating that we get a positive. Like you can't see it, or it's too bad. Like it's too messy. So, one thing, I'm trying to figure out how to say this and hopefully like doesn't come across in a way that like might make you feel bad, is like being able to figure out what I wrote because of what's happening. So what we have written down here is showing the multiplication. Right, so negative 1/2 gets multiplied by negative 3y. So you know that what I'm going to write down here is negative 1/2 times negative 3y. And then the negative 1/2, my second arrow up here, tells me to do the negative 1/2 times the 10. Guys, if you have the left one done, go ahead and do the right one. That's a 1/7 minus 3 or negative 3 times. Me? Because I look around. I don't stare at a computer all day, and I leave. Like, second block, I either go for a walk or sometimes run an errand. Like today, I needed gas, so I figured it's less busy out right now. So I ran and got gas. And when I go home, I don't stare at a screen. You want to see what I did on my snow day yesterday? Wow, rude. I was just going to start ignoring you if you were going to be mean to me. So, I've been working on this. I like to show you guys like what teachers do outside of school so you know we're not just like robots. So, this was all one piece of wood that came out of my friend's house. Close. Can you figure it out yet? Chessboard. So, it still needs glued up because I played chess and I felt like it. When you are an adult, you take on hobbies to occupy your time because you don't, well, especially an adult who doesn't have my own children, because I don't have kids who take up, like, way too much time. No offense, but y'all take up a lot of time. My dogs don't like to be in stuff, though. They would, like, sit on top of it. I'm not joking. If I made a doghouse, they would sit on top of it. I should just make them a little double-decker deck. Any questions on this one remaining? Gwen, I really appreciate how honest you are with like, hey, this doesn't make sense, I'm confused. So the first set here, a negative times a negative becomes the positive. Fraction multiplication is always top to top, bottom to bottom. So then over here, top to top, bottom to bottom, would be 10 over 2, but 10 over 2 is 5. And because it's negative times positive, what? Oh, it is this class. Sorry. Because it's oh, I didn't have the other class this week. Sorry, I thought it was yesterday, which meant today was safe, but you guys were yesterday. So, negative times positive. Do you not hear the D? When I say it quickly, I say negative. All right, let's do another one and see if it makes more sense, because this handwriting might be a little bit better too. So it's okay if you didn't finish getting that one 100% done. We're running out of time, so I want to show this whole process. And you had plenty of time to try this if you were going to try this. The one on the right, 1/7 minus 3 times 3/7 n minus 2/7. I don't ever write it as subtraction. Oh, come on, no one's going to be like, but wait. I wrote it as subtraction right here. So I'm not 100% anti-subtraction. Subtraction is a lie, and I think it's a bad idea, but you can write things like subtraction. Where is my pencil? So here I left it written like subtraction because I knew that I could tell myself, hey, that's actually negative 2/7. So then I skipped the middle step. I'm sorry. The 1/7 falls down. I skipped the middle step, so I'm going back to write the middle step. So then negative 3, which I'm going to make into a fraction, gets multiplied by 3/7 n. And negative 3, which I'll make into a fraction, gets multiplied by negative 2/7. I'm sorry, it's like autopilot at this point. Whoa, we'll get there. Cool your jets. I don't know where that expression came from, too. So, if we're writing out what's happening, then numerator, numerator, denominator, denominator. Numerator, numerator, denominator, denominator. It's like I'm singing. Becomes negative 9/7. I'm trying really hard. And becomes 6/7. Our like terms are our constants, but my variable remains negative. Sorry, now I have to see how fast can I say the word negative so I don't say it weird. Negative. 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 You don't. You could write it like minus. You could write 1 minus 9/7 n, and that would avoid saying the word negative, but but then you have to say minus, and we know subtraction isn't really real. The other option, and this is not just for Gwen, this is for anybody. The other option is this is all recorded. If you would rather take your like nice notes on an off, like a not at school day, on one of your off color days, it's not an off day, but it's an off color, right? It's not your color day. You can take your notes just off of my videos, right? You can go back and watch the video. This morning's class is already up, and actually they covered more questions than we have. I want to go through at least one more real fast because we need to get to that one. What? Hey, but this one I'm also just going to show it to you guys, so you don't have to necessarily write this down. This problem is a great example of if somebody says, hey, I have 3 Care Bears and 2 Pokemon. Oh, wait, I actually have 5 groups of that. The multiplication coming after what's in the group doesn't matter. What do I mean by that? Yeah, it doesn't matter. So check it. 3 minus 8y times negative 2.5 is the same thing as if the multiplication came first. I'm checking. I still have a minute. Fair, not really. So, we could do this in the other order, or like regardless, you'll get the same answer. So what I want you to see is you can either draw the arrows backwards or rewrite it with the multiplier first. may just be checking your notes on Friday when we take that quiz. So be ready.